Hi friends, I am Nagaraju from Vishnu Institute of Technology. This video is presented by me and my friends Sadiq and Lakshmi Prasanna. Let us know briefly about random forest. In this video, we will learn about all the contents in random forest. First one, applications of random forest. Second, what is classification? Third one, why should we use random forest? 4. What is random forest? 5th, how does a random forest works? 6. Use case. Here is flower analysis. Without wasting the time, I want to move to the next content, that is applications of random forest. First application in random forest is remote sensing. It is used in ETM devices to acquire images of the Earth's surface. Accuracy is higher and training time is less. Second application is object detection. Multi-class object detection is done using random forest algorithms. It provides better detection in complicated environments. Third application of random forest is Kinect. Random forest is used in a game console called Kinect. It tracks body movements and recreates it in the game. It is an example for Kinect. When an user performs a step, Kinect will register the movement and marks the user based on accuracy. First, we should train the computer to identify the body parts. Then the random forest classifier will learn from this. Next time, while dancing, it will identify the body parts and it will give the score to the game avatar based on accuracy. Let us know about the features of random forest. It is the most accurate learning algorithms. It works well for both classification and regression problems. It runs efficiently on large databases. It requires almost no input preparation. It performs implicit features selections. It can be easily grown in parallel. It have methods for balancing error in unbalanced datasets. Types of machine learning. There are mainly 3 types of machine learning. They are supervised learning, unsupervised learning, reinforcement learning. Random forest algorithm belongs to supervised learning because it will learn by giving some information. In supervised learning, there are 2 types, classification and regression. Regression is another topic, just leave it. Now we will discuss only about classification. Let us discuss what is classification. Classification is a kind of problem wherein the outputs are categorical in nature, like yes or no, true or false, 0 or 1. In classification, there are 4 types: KNN, naive Bayes, decision tree, random forest. We will discuss about only random forest. Why should we use random forest? Because no overfitting. Use of multiple trees reduces the risk of overfitting. Training time is also very less. High accuracy. Runs efficiently on large database. For large data, it produces highly accurate predictions. Estimates missing data. Random forest can maintain accuracy when a large proportion of data is missing. What is random forest? Random forest or random decision forest is a method that operates by constructing multiple decision trees during training phase. The decision of the majority of the trees is chosen by the random forest as the final decision. Let us understand deeply what is random forest. Here there are 3 decision trees. Output for first decision tree is an apple. For tree 2 it is mango. For third it is an apple. These 3 outputs will considered as random forest. From this there are 2 apples and 1 mango as outputs. We know that the majority of the outputs is considered as the final decision. So here the apple is the majority outputs. So the final decision is the apple. Let us know how does a random forest work. Let us consider this is the tree 1. Here there are apples, oranges and cherries. From the first bowl, is diameter greater than or equal to 3? If the diameter less than 3, then the condition will be false, otherwise true. So here cherries have diameter less than 3, but oranges and apples diameter is greater than or equal to 3. From these apples and oranges, again the condition that is color orange, apples fails the condition. So orange is the output for this tree 1. Let us consider this as tree 2. Here also there are apples, cherries and oranges. From the first bowl there is a condition that is color is equal to red. Here oranges color is not red. So oranges fails the condition. Cherries and apples comes true. From these apples and cherries, again the condition that is shape equal to circle. Here apples does not have circle shape, so it fails the condition. Cherries have the circle shape, so the output is cherries for this tree 2. Let us consider this as tree 3. Here also there are apples, cherries and oranges. From the first bowl there is a condition that is diameter equal to 1. Here apples and oranges will have diameter greater than 1, so cherries comes true. But from apples and oranges there is another condition that which fruit grows in summer. Apples does not grow in summer, oranges can grow in summer. So the output for this tree 3 is orange. Let us compare 3 trees to finalize the final decision. Here for tree 1 the output is orange, for tree 2 the output is cherry and for tree 3 the output is orange. We have already discussed that the majority of the output is considered as the final decision. So the final decision for this random forest is orange. Now let us discuss about use case of random forest iris flower analysis. Loading the library with the iris dataset. From sklearn.datasets, import load iris. Loading scikit random forest classifier library. From sklearn.ensemble, import random forest classifier. Loading pandas. Import pandas as PD. Loading numpy. Import numpy as np. Setting random seed np.random.seed of 0. Creating an object called iris with the iris data. Iris equal to load underscore iris parenthesis. Creating a data frame with the 4 future variables. df equal to pd.dataframe of iris.data comma columns equal to iris.future underscore names. Viewing the top 5 rows, df.head parenthesis. So we will get top 5 rows of the data set. Adding a new column for the species name, df of first of its species equal to pd.categorical.from underscore codes of iris.target comma iris.target underscore names. Viewing the top 5 rows, it will show the top 5 rows from the dataset. Let us train and test the data. Creating test and train data. df of first of is underscore train equal to np.random.uniform of 0, 1, length of df less than or equal to 0.75. Creating data frames with test rows and training rows. Train, test equal to df of is underscore train equal to true, df of of is underscore train equal to false. Show the number of observations for the test and training data frames. Print number of observations in the training data, length of train. Print number of observations in the test data, length of test. Number of observations in the training data equal to 118. Number of observations in the test data equal to 32. Create a list of the future columns names. Futures equal to df dot columns semicolon 4. View futures output. It will give the output index of square bracket sepal length, sepal width, petal width, d type equal to object. All are in centimeters. Converting each species name into digits. Y equal to pd dot factorize of train square bracket species of square bracket 0. Viewing target y array, it will give the output array of square bracket 0 0 and so on. Creating a random forest classifier. CLF equal to random forest classifier of n underscore jobs equal to 2 comma random underscore state equal to 0. Training the classifier. CLF dot fit of train square bracket futures comma y. It will give the output random forest classifier of bootstrap equal to true, class underscore weight equal to none and so on. Applying the trained classifier to the test. CLF dot predict of test square bracket futures. It will give the output array of square bracket 0 comma 0 and so on, 1 comma 1 and 2 comma 2 and so on. D type equal to int 64. Creating confusion matrix. PD dot cross tab of test square bracket species comma preds comma row names equal to square bracket actual species comma call names equal to square bracket predicted species. It will give the output predicted species Setosa versicolor Virginia. Thanks for watching video.